theorem. I asked you to do number 12, right? Okay, and I said to solve. The question says factorize. I said solve, right? Is there? Were you able to do them? Do I need to do any, all, some? Part one, right? Okay, so part one is x cubed. That's a minus, is it? Minus 4x squared minus x plus 4. Okay, so solve, so equals naught and solve. Okay, so find out what x stands for. How many answers is there going to be? 3, right? The highest power of x tells you how many answers is going to be, so there's going to be 3 answers. Okay, you have to guess the first one, so you try, does 1 work? So everywhere I see an x, put in a 1. 1 to be squared minus 1 plus 4, and into the calculator with that and see, does it work out? I think it works out to be 0, does it? Yeah, okay. So that means 1 is the solution. So if 1 is a solution, that means x minus 1 is a factor. That's the factor theorem right there. So if you have a solution, x, the opposite sign of the solution is a factor, okay? So then you do your division, okay, you do it out with your division sign or whatever way you do division. Now's not the time to learn a new way. Okay, so x cubed plus 4, I'm dividing it by x minus 1, so that would be x squared. That will be minus 4. I'm not talking you through this because you all know how to do this, right? That would be minus x squared, so that would be minus 3x squared. So that would be a minus 3x, just checking, plus 3x, minus 4x. Right, I'm good. So when I divide, my answer is x squared minus 3x minus 4. Okay, so you further factorize that, you're left with a quadratic. So you further factorize that, we have x and x, 4 and 1, a minus and a plus. So your factors of your cubic equation are the one you had originally, x minus 1, and then the 2 further ones you got after factorizing the quadratic, x minus 4 times x plus 1, right? Okay, they said factorize, I said continue on and solve, right? So you get, let each bracket equal naught, so you get x minus 1 equals naught, x minus 4 equals naught, x plus 1 equals naught, and that will give me x is equal to 1, x is equal to, x is equal to 4, and x is equal to minus 1. There's my 3 answers. Are we good? Right. Any other part you want done? It's all good? You all happy? Right, okay. Right, so I'm going to start the graphs of the cubic, but I'm going to give you more of the factor theorem tonight, okay? So, and I'm not going to do all of the graphs of the cubic and higher order, so I'm just going to do graphs of cubic functions. Okay, before we start, right, okay, if I have something like y is equal to something x plus a number, as in 2x plus 3, right, 3x minus 1, something like that, tell me what shape would that be? If a is positive, so if a is greater than naught, that would be a line going up, wouldn't it? Right, as in if the number in front of x is greater than naught, it'd be a line going up. And if the number in front of x was less than naught, as in was negative, it would have a negative slope, so it'd be coming down. Right, you all know that, don't you? Right, okay. If we have a quadratic equation, so something like ax squared plus bx plus c, right? And if I was to graph this, tell me, girls, if I was to graph something like that, what would it look like? It's smiley face or sad face, yeah? So if a is greater than naught, as in if the number in front of x, x squared is positive, when we're positive we're all smiling, right? Okay, and if a, the number in front of x squared, is negative, less than naught, negative, as in if that's a negative number, we're all sad, down in the dumps. Right? Is that okay? So we know all this, we learnt all this before, yeah? Is that okay? Right, so I'm going to talk about a cubic equation now. So a cubic equation is going to have an x cubed term and maybe an x squared term, doesn't have to have an x squared term, maybe an x term, and maybe a number by itself. Okay, so all it does is it has to have an x cubed term, the others are maybes. Sometimes maybe, maybe not. Okay, right, again, if a is positive, right, okay, so if the number in front of the x cubed is positive, what a cubic equation looks like is it's like a wave, right, okay, and if it's positive, we finish on a high. So we start low and we finish on a high. Is that okay? So it looks like that, right? And if a is less than naught, right, okay, we finish on a low. Okay, so that means we start high and we finish on a low. So it looks like that. So it's one wave in the middle for a cubic equation. Is that alright? Right, okay. Are we good there? Right, okay, so I want to talk about if it has three real roots. If it has three real roots, okay, like the ones you had last night, they had three real roots. You got three answers, okay? So if a cubic equation has three real roots, girls, that means it crosses the x-axis in three different places, okay? Is that alright? So it crosses the x-axis. Remember the roots are, you're actually finding where does the graph cross the x-axis. So if it crosses it three times, it's got three real roots. It's got three answers. Okay? Are we good with that? Right. What if I said this? Okay. Can anyone tell me what's happening here? Yeah, again it's got three real roots because it's an x cubed, right, but two of the roots are equal, right, it's got two of which repeat. Okay, so there's one answer, there's the second answer. So when you go to solve the quadratic, so you probably guess this answer, and when you go to solve the quadratic, girls, it will give you the same answer twice. Okay? So for example, the factors might be x plus 3, x minus 2. This is just me making up one, x minus 2. If I was to solve here, I would get x is minus 3. I would get x is 2, and then I get the same answer again, x is equal to 2. So there's still three answers, right? Okay, but two of them repeat, okay? And that's because it doesn't cross over the x-axis, it just hits the x-axis and goes back up. Is that alright? Are we good with that? Right, okay, and finally, right, the only other option, girls, is one real root. So again, there's still three answers, but two of them are imaginary numbers. As in, when you go to solve the quadratic, you'll end up trying to get the square root of a negative number which doesn't exist. Okay? Right? So it will look like this. So you see the way it only crosses the x-axis once. Right, and it never crosses again because it does its little loop up there. Or it could be, right, okay, it might I might start on a high and I might do its little loop down there. Basically it only crosses the x-axis once. Okay. Note, really important, all cubic equations have at least one real root. So there's never a case where there's no real roots. Iris, the phone. So there's never a case where there's no, all the roots are imaginary. There has to be at least one real. Is that okay? Right? There has to be at least one real. Okay? Now will I go on to the next bit? This is really important, right, because sometimes you'll be sketching. Graphing means you have to draw it accurately, but sometimes you'll just be drawing a sketch. So from the points you have, you'll be able to get the maximum and the minimum and the points where it cuts the x-axis, right? Then you'll be able to draw a rough sketch. Is that alright? Okay. Right. Am I good to go? So if you compare no, this is just another kind of what happens. Right, okay, if I was to draw the top one, okay, it's going to, if I was to solve, it would cross at 0, it would cross at 1, and it would cross at 2. Okay, so if you were to solve it, okay, that's the 3 points that you would, when you solve, that's what you would get. Sorry, move it down a small bit, yeah. Shape, please. So the x cubed term, right, means it's a wave. So it either starts high and ends low, starts low, ends high. Tell me what happens it's positive. So when we're positive, we finish on a high, right? So that means we start low and we finish on a high. So that's what that's going to look like. Okay? How do I know that? Because that number in front of x cubed is positive. Okay? So if it's positive, when we're in a positive mood, we finish on a high. Right? Got it? Okay? So basically, this one is starts low. Now, I don't know how far up it goes, or how far down it goes, but I know it'll look something like that. It's a sketch. A sketch is not accurate. Right? Okay? A sketch is a rough diagram, so this is a rough diagram. Are we good? Right. Okay. If I compare it with this one, can anyone see what happens? These are very similar. How did I go from one to the other? Double it, isn't it? Okay, so to go from that one, from f of x to g of x, I multiplied by 2, didn't I? Right? Okay, and what you'll find, girls, is when you draw the graph of that, when you draw the graph, again, it's a positive x cubed term, so that means it's going to finish on a high again. Agreed? Right, but what, and it'll still cross, when you solve it, it'll still cross at the exact same points. So when you solve that, you'll still get 0, 1 and 2. Right? So what's different about the graph, girls, is it goes twice, the peaks are twice as big. Right? So it goes up twice as high, right? So from here to here, so from here to the x-axis is double, okay? Right, and the same here, except I didn't draw it very well. Okay, I might change the black one, right, because the red one looks better to me. So if I just go like that, okay. So from here to there, and from here to that is double. It doesn't look double now, but remember it's a sketch, okay? So if I was to draw 3x squared minus 9x squared plus 6x, so if I multiplied everything by 3, it would be 3 times bigger, yeah? If I multiplied it by 4, it would still cross at the exact same points, but it would just be, it would be steeper, right? The waves would be steeper. Is that alright with everyone? Right, okay. And the last one I'm going to do for today is we're going to compare the graphs. Comparing so I'm just using the same example again, except g of x this time is going to be minus x cubed plus 3x squared minus 2x. How did I go from one to the other? How did I go from here to here? I multiplied by minus 1. Okay, so I multiplied by minus 1. Okay, so what happens there is the original graph, it crosses at 0, 1 and 2. It's positive, so it finishes on a high. So that means I start low, so I go up, up and up. Is that right? That's the original graph, so that's f of x. Okay, yes.
How do you know what process
I solved it. Right, okay, I solved it there last night. It's in the book. So I solved it. Right, but that's how you would find out. You would solve it. And the 3 answers are where it crosses the x-axis. So if you solve, and we learned how to solve yesterday, so when you solve, the 3 answers are where it crosses the x-axis. Got it? Okay, right. What about this graph? So I know this one was a positive x cubed, so it finished on a high. What about this one? It's a negative x cubed, so it finishes on a low. Okay, so it's going to look like that. It's the mirror image of it, girls. Okay, so it's the mirror image, so it'll still cross at 0, 1 and 2. If you solve it, you'll get the exact same solutions, right, except it's the mirror image of it. Okay, so g of x is the mirror image of it. Do you get what I'm saying? So a negative, it's the mirror image of it. What if I was to multiply by minus 2? So if I was to take the top graph, I was going to multiply it by minus 2. So minus 2x cubed plus 6x squared minus 4x. What if I was to draw that one? Okay, so I know if I multiplied it by 2, the peaks are twice as big, aren't they? What if I was to multiply it by minus 2? It'd be, yeah, so it's still going to cross at the exact same points, right? Okay, but it's going to be, and the peaks are going to be twice as big. Oh, sorry. So the peaks are going to be twice as big. So from here to here and from here to here is double. Right? Okay. Is that right? Because I multiplied it by a minus, it turns it, reverses it, right? And I doubled it, so that makes it, the peaks twice as big, but it always crosses at the same point. Would you agree? Yes, you would, because I just told you. Right, I think that's enough new stuff for today. We'll go on with the, I'm not finished that section by any means, but I think I've thrown enough information actually to process today, okay? So what we'll do is we're going to solve some more cubic equations. So we're still working on the factor theorem from last night. So we'll do page 81, question 17. And I'll see, is there basic questions from these? No. No, I haven't enough done to give you questions out of the next bit. So, and let's do a couple of harder ones there. Question 20 and question 21. Okay? So page 81, 17, 20 and 21, and I'll stick it up and you can get started now. If anyone has any questions, now's the time to ask them.